All right. Good. We've talked about the interim test for divergence, okay, which is again, it's just what we've already done. Generally, it's difficult to find the exact sum of theories. The exceptions are geometric series, because we actually have a formula to find the exact sum if it converges. And special cases like a telescoping series. Therefore, we'll mostly be concerned about whether or not a series converges to a sum or not concern ourselves with finding that sum. So it's going to be, does it converge or diverge? So the first test that we learned, was the interim test for divergence, and that's when we have a function n over another function n. So for example, on number one here, does this diverge or unknown kind of thing? So in this case, because this limit as n approaches infinity is what? 5/2, and that is not equal to 0. This diverges. Now, number two, what kind of function is this? Or what kind of series is this? Exponential. Now, since we have 5n plus 1, this is 4n times 5 over n times 1 over 5 to get rid of that plus 1. Right? Now, my initial value, so a of 1, if I plug in 1, I get 4/5 times 1/5, which gives me 4 over 3.5. My rate is 4 over 5. Now, since my rate is, the absolute value of my rate is less than 0, this will converge, and we will find a value for this. So because this is less than 1, this converges. And we can plug the formula a of 1 over 1 minus r. So 4 over 25 over 1 minus 4/5.
4 over 25 divided by 1/5, so that's just 4 over 5.
Yeah, so 4/5. Now, number three, this is a specific type of P series. It's that harmonic one. Remember the harmonic one, does it converge or diverge?
Diverge.
It diverges. And P is less than or equal to 1, so this diverges. P is greater than 1. Absolute value P is P is greater than R. So P is greater than 1, then it will converge.
What's the first type of series?
It's not really a name, it's just we have a function of n over itself. Now, we are going to learn today about another test called the integral test. So here's another test to determine if a series is convergent or divergent. So the integral test f of n is equal to a of n. To use this test, f must be continuous, positive, and decreasing on the interval from 1 to 8. So again, we're going to have a lot of little functions series that we have to be able to identify. So that's why I mean, hopefully, you see just we go back and do a few review stuff as we go on, so we can kind of, hey, you already learned this, just look at apply it, make sure we're good, and move on. So again, we talked about geometric, we talked about the harmonic P series, and we talked about the n test for divergence. We know when each situation occurs. That's it's really kind of hard. Once we know what tests we need to do, the test itself is really not bad. All right. So f must be positive. Function must be positive. continuous, and decreasing on the interval from 1 to infinity. If the integral of 1 to infinity of fx dx is convergent, then the sum from 1 to infinity of a is convergent. If it's interval from 1 to infinity of fx dx is divergent, and so it's the sum. So the most common use is the p-series. Right, so there's another way we can test the p-series. Instead of just saying what it is, we can actually test it. So if p is greater than 1, if the p-series, the sum of n goes to infinity of 1 over n to the p power, converges if p is greater than 1, and diverges if p is less than or equal to 1. Kind of as we just saw. So let's look at this. Now we do know that this is a p-series, right? All right. Because of the p-series, this is the exponent is 1/4, right? Now, since it's one less than 1, then this should do what? We are going to do the interval test. Okay. So we're going to take. Well, first we have to determine if it meets the criteria. Right? Is this function continuous?
Yes.
Yes. Is it positive? Yes. Right? Is it decreasing from 1 to infinity? And we're looking at specifically the interval from 1 to infinity. So it is continuous on that interval. It is positive on that interval. And it is decreasing.
Wait. How is it positive and it's decreasing?
This decreasing function.
Oh, what? Yeah, but like the whole function. So like the down part.
Yeah. You're getting closer.
It's like when it approaches.
Decreasing.
Yeah. Because the greater the number, the greater the fourth root is, and then the smaller the fraction.
So let's look at the integral from 1 to infinity. In the to the negative 1/4 power. D.
It's true units.
Yes.
So can it like be, it can violate those rules if it's like before one?
Yeah, this is before 1, it just have to do this. 1 is a continuous at 0.
No.
No, it's not there's a 0. Oh, it's just a 0. So, yeah, it's specifically on that interval. Why that interval? The sum starts at n is 1.
So if it started at 0, well,
Then, yeah, if it starts 0, then you'd have to change the criteria. But on all these subs, it starts at 1. Again, for this specifically, these subs. All right. So what we're going to do is we are going to change this to be the limit as t goes to infinity of the integral from the t into the negative 1/4 dx. So we remove the infinity out of the upper bound, replacing t, and we're saying as t goes to infinity, what's happening? All right. What is this interval?
Is it t to the negative 1 minus 1 with more than that?
Put in t, just yeah, there. What is the antiderivative of this function? 4 thirds times n to the 3/4 from 1 to t, which gives you the limit as t goes to infinity. If I plug in t, I get 4/3 t to the 3/4 minus 4/3, right? Now, as t goes to infinity, what does this go to?
It's just, it's bigger and bigger.
Goes to infinity. And if it goes to infinity, is that conversion or back? Conversion means it would go to what? A specific value. It would go to 0 or 3/4, 4/3, whatever that is. So because it goes to infinity, this is convergence. Convergence. Well, class hash, yeah, plenty of room to do all this. Does this meet the criteria? From 1 to infinity, is it continuous? Yep. Right. Is it positive? Yeah. Is it decreasing? Yeah. It's a 1/e bit. So we're going to take the integral from 1 to infinity of e to the negative n dn. Again, to actually do this, we're going to write this as limit as t goes to infinity from 1 to t e to the negative, which would give you limit as t goes to infinity of what? Negative e. Yeah, negative. Right, 1/e. Yeah. Derivatives 1/e to the n. Well, the derivative of 1/e to the n would be negative e to the n.
And then,
So
we should make.
So cancel out that negative e.
Oh,
Which gives you, sorry, yes.
right. Wait, what is the? How do we get to 1.9? Don't you have to add? Or can you just do the negative and from 1 to?
Shading on this one.
Yeah.
So it's not so much adding 1 to the exponent, it's what's the derivative of e to the x? E to the x.
Yeah.
So derivative e to the n, again, now it's a negative, you have to change, so it's negative e to the n. But we have positive, so what would cancel out the negative? Another negative. So negative e to the negative n, which is negative 1/e. Now, as we plug in t in 1, we get what? Limits as t goes to infinity of negative 1/e t plus 1/e. Now, as t goes to infinity, what is this approach? 1/e. The empty function when t goes to infinity, which means you get basically 0. But plus 1/e gives you 1/e. So this is going to converge to what?
1.
Yeah. And again, I don't know if that's going to be the actual value it converges to, but we do know that this converges.
I thought the whole process was finding was to find what it converges to. I thought that was good.
It just says if it will converge or diverge. I think it said at the beginning, we were mostly concerned about whether or not the series converges to a sum, and not concerned with self-defining the value of the sum.
Uh,
So again, it's going to be divergent, convergent. That's what we're looking for. What? function is this. How can I write this as a sum? Is n goes from 1 to infinity of what?
4 minus 1 to 4.
That's what I already did.
On the last one, it doesn't converge to 1/e, we just know it's converging.
Yeah. Wouldn't that's conversion to 1/e because that's what you get it equals if n equals 1. If you add 1, then 1/e squared, 1/e.
Should be less than that because you're subtracting this.
It should be a little bit more. I'm subtracting. Maybe I'm subtracting.
Negative 1 over e plus.
That's the end.
That's the integral. The integral does not give us the value here. The integral just tells us if it's convergent. It's just a test to let us know if it converges to a value or not. It doesn't give us the value because that's just the initial value. If you do plug in 1. Yeah, just to reinforce that the integral test does not give us a value. It just lets us know whether it converges or diverges. So if we get infinity, then what's our answer? It diverges. If we get anything other than infinity, it's convergent. So that's it. So for this one, well, to infinity. It's one.
Integral's a type of summation.
Mhm. Into t. Or in minus 1. Then. So what is that interval? Yeah. Things. As t goes to infinity, 1/4 log in minus 1 from 1 to t. You would have to do the u substitution. You could use u substitution, or again, we do know it's a chain. What's the derivative of the denominator?
1 or 4.
Yeah, so
1.
you have to take out a 1/4. That's it. To cancel out 4, what would cancel out 4? 1/4.
So, graph goes like this, right? Graph goes like that, so it should be like a version 0.
Which one? Well, we'll see.
So it should, it should be a version 0.
What do we get if we plug in? No. We plug in the values. We have 1/4 of natural log of 4t minus 1. Yeah, natural log plus what? Or minus what?
Log 0. Right.
If you plug in 1, you get 3. Natural log. Yeah. Minus natural log.
1/4.
Yeah, I just put 1/4. That's now. As t goes to infinity, what does the natural log do?
It gets 0.
That's it. Actually, natural logs look like natural logs actually grab that. So approach is what? And what's infinity plus natural log of 3? So forgot to write the limits. St goes to infinity here as well. So this gives you infinity, which means what? Divergent. Oh. We'll see in a second.
I see those.
Okay.
I'm right. Wait, do we have to like change how it's written since it starts at 3?
We would take the integral as from 3 to infinity. But yeah, we would change our condition though. Because it's a good catch. This one does been at 3, which means I would change my condition to be from 3 to infinity. Is it what? Is it constant? Is the word continuous? There shouldn't be a problem plugging in 3 there, should there? I don't think so. So yeah, it's continuous. Is it positive?
No, it is. I thought natural log could be negative.
It can be if the inside is between 0 and 1.
But it's not. It's between.
Yeah, it's 3 and 0. So yeah. So it's still positive. And what you can't do in 10 natural log is put in the negative value. You can't do a natural log of a negative. What's the other one? Is it decreasing?
Yes.
All right. So yeah, it is decreasing. The bigger your boundary, because that's 3. The bigger that gets, you're going to get what? A smaller value. So yes, it is decreasing. So it does meet all the criteria. So we are going to integrate from 3 to infinity. What? And natural log it in, natural log of the natural log of it in.
I don't know what to do if I saw some CC there.
Not just with both of those tests and the with that last one's out. No, I have 2. I'm gonna retake this one. Okay, so they're I can retake them. Dang.
All right. Now, Ian. We know this is going to become the limit as t goes to infinity of 3 to the t, 1 over n the natural log of when natural log of natural log n n. You think you could solve this? Use substitution. Substitution. So u is equal to the natural log of the natural log.
It's actually equal to n of the natural log of n of the natural. Oh wait, no. You're just trying to do. What the hell?
I can do that.
One over.
1 over, right? Times, what's the derivative what's inside?
The natural 1 over.
1 over n. So that gives you 1 over n natural log n. Do we have n natural log n?
Oh, we do.
We do. This becomes integral from 3.
That's so.
Now we do want to plug in our bounds through the substitution as well.
Oh, yeah.
So we are going to write the bounds now as the natural log of the natural log of 3 and the natural log of the natural log of t.
Isn't the natural log of
I can't
the natural log of infinity still infinity? So yeah, that's fair. Right now.
And we're still going the limit as t goes to infinity of 1 over what?
You.
U. That's not too bad.
This is.
One part. What's the derivative? What's the integral of 1 over u?
L
Natural log of u.
LA.
There's time.
This is
Oh
the
my
best question I've ever had.
That's
Okay. So this will give you the limit as t goes to infinity of the natural log of u from the natural log of the natural log of 3 to the natural log of t. Plugging that in, you are going to get the limit as t goes to infinity of the natural log. And this should be technically absolute value, don't forget. Yeah, value of the natural log of the natural log of t.
Doesn't want to ever use this.
No one else.
Minus the natural log of the natural log of the natural log of 3.
What is that?
We had fire whoever made this question.
It's this question. It's just an amazing question.
What is it?
Why?
That's
Like, what is going on here?
What is that, Ellen?
Last one?
Ellen.
There's 3 Ellen. There's 3 Ellen. Of Ellen of t. And then minus Ln as the value of Ln of Ln of 3.
Okay.
So there's 3 Ln's each side. Ln at the value Ln parentheses Ln and then whatever. T.
That's the worst.
And here's the fun thing: as t goes to infinity, what does this become?
This is not a
It goes to infinity. Means it's divergent.
I don't think we needed all that just to say it was.
I gotta show this to other people. We're gonna go write this on the board in the math lounge.
You
So
should
we'll have the same reaction you guys do.
write it on the board for your geometry class and just say, all right, this is what we're doing today.
Extra credit.
After loss. I'm taking out for 2.
Exactly.
I will not be.
I'll just plug it in a calculator and get the right answer. All that for to be divergent.
Test.
Then I'll probably.
I'm not gonna say that.
Off freaking bridge.
I love this question. I have laughed.
This is on the test.
Yeah. This is even. Okay. What's the moving down? Alright.
That's number 8.
Massage.
Class. Too much.
We'll get Monday to go finish, so I would like to get to the ordinary comparison test.
What time is it?
Gee, I think
There's no freaking way.
I've been here that long.
We have 20 minutes.
There's no way.
We've only done like a half page.
I know, this one.
No,
Like, I think
we didn't write. Alright, so we're going to go from what, 2 to infinity here? So, is this continuous?
Yes.
Yep. Now, why wouldn't 1 work here? 1 wouldn't actually work here, would it? So yeah, it's continuous. Is it positive? Yeah. Is it decreasing? Yeah. So it meets all the requirements. So integrate from 2 to infinity. Plus n squared minus 1 n becomes the limit as t goes to infinity to t over a longer minus 1.
Isn't it the great thing or I'm thinking wrong?
Now, no, this is not a trig one. It would be FE1 plus. No. So this will be natural log, but it will be that chain, so you do need to do use substitution here.
I think maybe you could do your substitution, but I'm gonna do 1 over, or I'm gonna do Ln of n squared minus 4.
Nope. We're gonna do something else.
Well, wouldn't that work?
This will not be that.
But wait, why wouldn't it work? Did I put 2n in front and then,
What if we write this,
no?
say, what if we write this as limit as t goes to infinity up to t of 1 over plus 1 and minus 1. Now, partial fractions.
Wait, no, I'm like, genuinely, why are we making this happen? Would it not work the other way?
How would you?
Like, if I were to do 2 ln, or sorry, yeah, 2,
No, it wouldn't, because we'd have to do substitution, and to do your substitution, we would get 2 in, and we don't have 2 in.
Well, why would we have to really do substitution and not what we did on number 6? Yeah, why wouldn't we do what we did on number 6?
Because the E is real simple.
No.
Integration 1 over E is real simple.
Why could
No, number 6, there is no E. Why?
Why could we
Because
just?
you did do your substitution.
Why?
You just did it quickly.
Why couldn't we just keep what we have and then do 2n ln and minus 1?
Because we don't have a 2 in. To do substitution, we have to actually substitute E in or 2 in. You don't have 2 in.
The 2n.
We don't have it. So we have to do our fractions. So-
Because it's calculus, that's what we do.
You know, originally someone just made up theories and algorithms, and that's how calculus was invented, so.
So you guys still talking about it? Okay. So partial fractions. We are gonna have, again, A over N plus 1 plus B over N minus 1, which will give you, 1 is equal to A N minus 1 plus B times N plus 1. Now, yeah, no, it's not one space. How do we solve our partial fractions?
We find when n is equal to 0,
Yeah, we take our zeros
Yeah.
and plug them in and see what we get for A and B. So if n is 1, that would cancel this out and give us 2 times B equals 1, which gives you B is what?
1.
1 half. 2 times B equals 1. So B would have to be 1 half. Now if n is negative 1, we would get negative 2A is equal to 1, which gives you A is negative 1. So this is going to become limit as t goes to infinity, integral from 2 to t of negative 1 half over n plus 1 plus 1 half over n minus 1. Yes.
Could we
We can write this. Yes.
1 over 2 plus n minus 1 over 2?
We can just do 2 negative 1 over 2n plus 2. It's fine to leave it like that. Because, wow.
What?
Unfound.
So now, Kate, when you do the integral of each, what are you going to do with the negative and positive half? Just bring them out. Okay. So what is the integral of 1 over n plus 1?
I don't know.
Natural log of n plus 1?
So,
Yeah.
Yeah, it kind of is.
it might be, but
So this gives you the limit as t goes to infinity of negative 1 half natural log of n plus 1 plus 1 half natural log of n minus 1 from 2 to infinity. Now, here's the fun part.
We've read it all out.
Here's the fun part.
Oh.
Do you remember your rules of logarithms?
I was gonna say LNs.
What do you do if you're adding or subtracting? In this case, I would have to take out a negative 1 half, right?
There's just multiple.
No, not quite.
could
Because if we take out the negative 1 half, same thing,
estimate?
we get the natural log of n, well, natural log of n plus 1 minus natural log of n minus 1 from 2 to infinity, which would give us as t goes to infinity of negative 1 half of the natural log of n plus 1 over n minus 1 from 2 to infinity.
Wait, what? Oh, yeah, we can divide them by 2, yeah. This is 2.
It's not going to infinity. It doesn't even be wasting our time here.
So we get negative, the limit I'm sorry. Should be T, right? Not, you're right, infinity, it should be T.
Oh my god. This is a thing.
Actually.
So much for this.
The natural log of T plus 1 over T minus 1. And what do I get if I plug in 2? So I get negative 1/2 times natural log of 2, right?
No, 3/2.
Should be plus 1/2. 2. If I plug in 2, I get, no, it should be 3. 3. Is, you're right. What do I see goes to infinity here?
1. I call it 1.
Yeah. Because the ratio of coefficients is 1 over 1, right? So this will approach 1. So we get negative 1/2 equals, hold on, right here. Negative 1/2 times the natural log of 1 plus 1/2 natural log of 3. What's the natural log of 1? 0, right?
So 0 plus.
Just gives us that, which means this is what? Convergence.
Yeah, it doesn't say it's conversion, well, you know what value it is.
Matter what that. This matters, that's conversion.
And we know the version. It's just.
Oh,
Goes on. I feel like the laws gears off on one. We should be done. Like what happened? We should be done today. Because.
Now, welcome to some. What's really fun is on the notes. If you look at the answer key, I did post the answer key. The answer key's wrong.
Yeah. No.
That's correct.
That's one.
They randomly changed from 2 to T to 3 to T for some reason.
I would.
I don't know why.
What?
So first, again, people make mistakes. I'm not above making mistakes, so I'm surprised if I made a mistake. I did make a mistake and I fix it.
What if it's not conversion?
But it is converged. It is still converged.
Element of 1 minus.
Yeah. It shouldn't be, the answer they get isn't negative 1/2 natural log of 1/2.
Will there be faster ways to do this? Is it really help
Don't
solve
be-
that? Maybe.
Man, not better ways,
Oh, yeah.
just other ways.
Well,
What's time?
it's positive and negative.
We got
10 minutes.
It's 13 minutes.
10.
Let's finish this page.
Is there a way to like
Wait.
grab that, like
Wait.
the answer
Wait.
or something,
Wait.
instead of doing what that is?
Ordinary comparison, that's there's OCT. Let A be equal to 1 over 2 to the power of n, and B be equal to 1 over 2 to the power of n plus 1. Route first 5 terms in the series. So, what do you get for A if n is 1? 2. Well, n is 2. 4. And n is 3. 8. N is 4. N is 5.
This is the delta map. Wait, so isn't there like a series is when you add them and then a sequence is when it's just it's not.
Yes.
Oh.
Summation do that. What about what's the other one? All we're doing here is adding 1 to the number percent, right? So 1/3 plus 1/5 plus 1/9 plus 1/17 plus 1/30.
Yeah, we're almost done, guys.
Today.
This means A of n is greater than B of n for all values of n greater than 1.
It is great. Because 1/2 is greater than 1/3, 1/4 is greater than 1/5, 1/8 is greater than 1/9. Since this is geometric, you can have a sum, so what is the sum?
Isn't it 2?
The value is 1/2, right?
1/2 times 2. divided by the rate, minus 1 minus 1
It's
is
just
5.
One.
You won.
Yeah, one.
Based on the above, what can we conclude about the sum of b in? It should be what?
It should be less than 1.
Less than 1. So since a of n is greater than b of n, and the sum at n equals 1 to infinity of a of n is equal to 1, sum n equals 1 to infinity of b of n should be less than 1. Less than or equal to 1. Which means that what? So it must converge. And this value right here will be what's called up or down. Converted. Max value. All right. That's next thing.
Yeah.
We already talked about ordinary comparison tests, Monday, and then limit comparison tests. Then do some practice questions. Tuesday, we start off with a series. And we just kind of keep going. Keep going. We have only this week and, or sorry, next week and the week after before spring break. Or 2 weeks before spring break.
Depends before spring break?
No, that's,
No,
no, there's no way.
no way.
No way.
What do you think? So I have to study over spring break.
No, I'll just give you guys a bunch of homework.
Well,